Homework Hotline, what is your emergency?
Hi everyone, and welcome to the Homework Hotline.
We're here live every Tuesday and Wednesday from 4:30 to 5:30. We want to help you with your homework questions.
If you call us, we'll interact with you and walk you through your problem. Calling is really the best way to get your question answered. Our number is 720-424-1666.
And we have a few ways you can watch us live. We have Comcast Channel 22, Prism TV Channel 8007, YouTube Live at Denver DPS TV, Facebook Live at EG Homework, or live stream at livestream.com. Just search for DPS TV 22.
We're here to help you with math and science. I'm Becca. I can help you with math. This is Nathan. He can also help you with math. Over there is Sam. He can help you with science. We both teach Emily Griffith High School, and Sam teach at Emily Griffith High School, and Sam teaches at Contemporary Learning Academy.
On Tuesdays, we have special guests. So today we will have Elizabeth Nosik, the Curator of Education and Exhibits for the Colorado Railroad Museum. One of the things Elizabeth will talk about is trains and food. So I have to ask, do you think you can eat chocolate mousse in a caboose?
Maybe we'll find out, Nate. Though we prefer to get your phone calls, we know calling isn't always the easiest thing for you to do. So we have somebody monitoring social media. You want to tell us a little bit about what you do over there?
Hi, I'm Jack. I'm an intern here at DPS TV. If you would like to send in your questions over email, Facebook, Twitter, I am the one who can pull those for you. I'm also the one that gives the trivia question at the beginning and the end of the show. So today's trivia question is an earth science question, actually. It is, what is the deepest part of the ocean?
Well, if you think you have an answer to the trivia question, then you can give us a call. You can send in your questions via social media to Jack. We'll give you that contact information on your screen right now, just in case you've got some questions ready for us. If you send in your information send in your question to Jack, you can send it in on Twitter or Facebook. So trivia or Facebook, hang on. Train of thought. We were speaking about trains, and that's how it went.
Just working that pun in there.
Exactly.
Well done.
Exactly. So you can send in your questions, your homework questions, on Facebook or Twitter, but I'll give you those in just a second. Let's get the question from Jack one more time.
Yeah, if you missed the trivia question, again, it is an earth science question. What is the deepest parts of the ocean?
There we go. So let's try that again. If you have an answer to that trivia question, or if you have questions to ask to us for your homework, you can get a hold of us in a few different ways. You can call the number on top of the screen there, 720-424-1666. As we mentioned, that's the best way to contact us. It's immediate, and we can interact with you. But you can also get a hold of us on social media, Facebook and Twitter at EG Homework. You can text us at 970-680-3771, or you could email us at homework@emilygriffith.edu. So if you've got an answer to trivia, or if you have any homework questions to ask, those are the ways to get in contact with us. Oh, I should mention that there is a prize for answering the trivia question correctly, and that's 2 symphony tickets. Is that still correct?
Right, and I think it's symphonies that you choose. Right? I think they're open tickets.
Okay, open tickets. 2 symphony tickets of your choice then. So, all right. Well, we're going to go ahead back to social media, back to Jack, and get some questions that have been left for us throughout the week. We'll get those answered.
Okay, so it looks like we're actually going to be starting out with a science question today. If we can get this thing to cooperate here. Okay, so at 100 degrees Fahrenheit, which of the following substances would be the hottest to touch? Wood, water, sand, or gold?
Ooh, okay. So I'm guessing that this is a question that's wondering about heat retention. Ooh. So I would think that any substance, if the substance itself was 100 degrees Fahrenheit, should feel roughly the same way. You know what, Jack? I don't actually know. I'm going to think about this one, and if I can come up with a better answer, I will offer it back. But at this point, I would say anything at 100 degrees, I would think should be the same experience for any of those substances. Maybe that's not true, though. I'll look it
Is
up.
that one of the choices?
No, it's the choices has it as one. So I'll try to think about it.
All right, let's go get another question.
Let's see if we could find another good science one here. This one looks like it has to do with photosynthesis. So this one is, in which parts of a plant cell does photosynthesis occur?
Okay, so let's look at a plant cell. All right. Give me just a sec here to pull this up. Okay, well, while it's pulling up. So cells are the basic unit of life, and within every cell, there are a lot of different parts of the cell that are referred to as organelles, which essentially means little organs. It's a way of describing different pieces inside of the cell that perform different functions, just like different organs inside our bodies perform different functions for us. So if we take a look here, this is sort of a basic diagram of a plant cell. Each of the different labeled parts is a unique organelle, and each kind of has its own function. One organelle that is unique to plants is the chloroplast, so it's kind of highlighted here. It's this green-looking guy, and the chloroplast contains various different things, including chlorophyll. Chlorophyll is the chemical that gives plants their green color, and is also a chemical that's important in photosynthesis. So within a chloroplast, you have a fluid surrounding little tiny sacs, kind of just barely visible in this picture. But the little edges that you see inside the chloroplast are little tiny sacs called thylakoids, and thylakoids are one of the places where photosynthesis happens, essentially through energy from the sun exciting electrons that are inside of that chloroplast, creating an electrical flow that allows the plant to use some of that energy to turn carbon dioxide and water into sugar, which is the basic function of photosynthesis. So anyways, the answer to the question is the chloroplast, and it's unique to photosynthesizing plant cells.
Very nice. Well, let's go back to Jack and see if we have any more questions waiting for us on social media.
All right, it does look like we have plenty of science questions still here to go. So the next one, how about we do this one, has to do with helium. How does helium change the sound of your voice?
Oh,
So another science question.
Oh, yeah.
putting you to work today, Sam.
Yeah, so it has to do with air pressure and frequency. I'm not really sure. I was thinking about something else. Is there any chance we could do a math question? And there's a reason we're doing a series of science questions?
Oh, we're having some technical difficulties
Oh, you guys
with the display. I realize you don't hear that conversation.
Yeah, I don't hear that conversation. Okay, sorry. So let's see. So helium raises your voice, and then there's another kind of a chemical called sulfur pentafluoride, which would actually lower your voice. And the essential idea is that these different chemicals create different air pressures, and so the frequency of your voice changes. The frequency of your voice should rise as it passes through helium, because I believe it's a lower pressure gas. Whereas sulfur pentafluoride, which is another gas, which is fairly dense, it's much harder for your voice to travel through there, so the frequency of your voice lowers, which makes it a lower sound. I believe that's the case. I will double check that. I was still trying to figure out the question related to whether 100-degree wood or 100-degree gold was hotter to the touch. I still can't tell. I'm not entirely sure. So, Jack, do you want to give me another?
That's okay. We're about ready to go on and do some math questions now. So.
All right. Man,
First
we made
one
you work
here.
there, Sam. Thank you.
Thank you guys. Sorry, I was not ready for that.
Okay, the first math question we have here, the sum of two numbers is 16 and their product is 55. What are the two numbers?
Yeah, I can take that one. That is a system of equations problem. So what you notice here, and I'm going to write out some of this, we're saying that the sum of two numbers, and the reason why I'm writing this out is because I find that oftentimes, especially I'm teaching this in advanced algebra right now as kind of a review for algebra. One second. And I find that sometimes like the hardest part about these problems is actually figuring out what it's asking and how to set up proper equations. So I'm going to say find the two numbers. So I'm going to kind of walk through how we would think about this. Because again, I think that's the most challenging part. If you're doing a problem like this, I'm assuming you've already solved some systems of equations using some like elimination and substitution, different methods like that. So I'm assuming that you're just kind of struggling with writing things algebraically in this case. So one of the things that we always talk about here is if you're trying to solve any kind of equation or any kind of word problem, application problem, the best thing to start with is always to think about what are you looking for, like what are the variables you don't know what they are or that you're looking for, and how can you set those up. I'm going to go ahead and say that I have two numbers that I don't know. Well, let's take a step back. One thing that students often try to do is just guess on a bunch of these, and they say, okay, the two numbers that add up to 16 are 8 and 8. Do those multiply? I forgot to write product in here. Do those multiply to give me 55? Well, 8 times 8, let's see, the product is 8 times 8 is 64, so that doesn't work. And you can keep on guessing and checking all these different things, and you might find one of two things, that the numbers might not be whole numbers, in which case you have to guess all these crazy decimals. You might also find that sometimes the numbers we work with are bigger, and it might just take a very, very long time. So we like to do this algebraically. And we're going to think, I'm going to just set up, we want to know two numbers, so I'm going to set up two variables. And I'm going to call x my first number, and y is my second number. And again, if you just set these up, sometimes just the act of writing down that x is representing a number and y is representing a number is going to help you set up these equations. So if I look at this first part, the sum of two numbers is 16. So that in itself, I just think add up two numbers and they should add up to 16. I think that's fairly straightforward, but we need to include these variables that we identified. So if x is a number and y is a number, the sum of the two numbers would just be x plus y. And we're saying added up equals 16. Often when we have these problems, this word is, you could think of as equals, and sum we should be thinking of as plus. So if I just have this piece of the equation, I would automatically think I don't have enough information to figure out what either one of the numbers is individually, because I have two variables. In order to solve for either of them, I have to have two equations. So this second part is saying, and their product is up here because I forgot to write it, is 55. So when we think of product, you should be thinking up here, multiplication. So I'm going to put a dot because I'm using x for multiplication. I'm using that times symbol. Now, same idea. If x plus y is 16, that's the sum. Product is going to be x times y is 55. So now I have two equations and I have two variables, so I can solve this. So one thing that we're going to do is called the substitution method. If you have learned elimination method, it's not going to work in this case because in one case we're doing sum, the other one we're doing product, so we don't have equivalent operations there. And really, in order to do elimination, you need two kind of addition type problems. So when we do substitution, what we're really trying to do is solve for one of these variables in terms of the other. I'm going to pick this one because I think it's a little bit easier to work with. So x plus y equals 16. I'm going to pick one of these, and I don't really care which one it is, but I'm going to solve for x. So in order to solve for x here, I need to get x by itself. So I'm going to subtract y from both sides. and I'm going to get x equals 16 minus y. All right, so with this now, I've solved for x in terms of y, and again, we said one of our problems with these equations is I have two variables. So now what I can do with this is I can say, look, I know x equals 16 minus y, which means I can replace this value of x right here. So I'm going to take this 16 minus y over here, and I'm going to plug it in. So I got 16 minus y times y equals 55. And so if you look at this, all I did is I solved for y, and I said, OK, I know x is equal to something else, so I can plug that in. That's my substitution. Now I've got an equation right here that I'm going to highlight in yellow. This is an equation we can solve because I have one variable in one equation. So I'm going to get 16y minus y squared equals 55. And now I'm going to go through this a little bit quicker in solving for y, just because I don't want to talk for 15 minutes about this one problem. But also, I'm assuming that if you're at this point, you're comfortable solving quadratic equations. And you should know this is quadratic because our biggest exponent is squared. So I'm going to rewrite this. If you remember, solving quadratics, oftentimes we need to set one side equal to 0. So in this case, because my y is negative, I'm going to move the y over to the other side. So I'm going to add y squared, and I'm also going to do this in the same step. Subtract 16y from each side. You notice these are going to cancel out. So I'm left with 0. So 0 equals y squared minus 16y plus 55. All right. So now we have a few options in terms of how to solve this.
We could factor it.
We could factor it, do
and in
zero
that
product
case, guess
property.
what we would be doing? I just find it's funny.
What's that?
If we factor it, we're finding something whose product is 15 and adds to give us negative 16.
Wow. That is actually pretty funny.
Sorry,
it's kind of a nerdy math joke.
But
But yeah, actually we are factoring this. So when we factor, which is funny because the problem is saying two numbers that add up to something and multiply to get something else, we're doing kind of exactly that thing, which I said let's not do that at the beginning because we have to guess and check a lot. But now with factoring, we're going to guess and check. So yeah, that is actually pretty funny. OK, so we're going to factor this. And again, I'm assuming that you're comfortable with this. If you are not sure what we're doing here, and this was your question, I would look up solving by factoring or solving quadratics by factoring. But like Becca said, what we're doing is finding the factors of 55 that are going to add up to negative 16. In this case, so I'm going to have a y here, a y here. It's going to be negative 11 and negative 5. Right? Negative 5 times negative 11 gives us that positive 55. And then adding them together, I get the negative 16. So using zero product property, we could set each of these equal to 0. Y minus 5 equals 0. Y minus 11 equals 0. And I get y equals 5 or y equals 11. You will find this is kind of an interesting problem because right now we're saying there's two possible solutions for y. This happens a lot when we're doing kind of some more advanced algebra stuff where we have two possible solutions, but one we can eliminate because it's negative and we can't have a negative number. In this case, the reason why we get two possible numbers is because we don't really have to distinguish which one is x and which one is y. I solved this one for y. But if we look at my original equation, it's not saying y is the first number or the second number. It's not saying y is bigger. There's no constraints there. So I could have just as easily made this y plus x and this y times x, and we could have flipped everything around, which means if you actually think about it, this could either be the first number or the second number. So our numbers are 5 and 11. So actually, what Becca said is we eventually got to a point where we had to do this guess and check. We could have done the guess and check to start with, and we probably would have saved, well, you can look at your clock and see how much time we would have saved. But the point I was making earlier is like that method is not always going to work for every problem. Mm-hmm. So this is the very long way to do a problem that I did guess and check.
Ended up having a super obvious answer.
Yeah. So We could check our answers by now saying, okay, do these two numbers add up to 16? Yes. Is their product 55? Yes. That is our very long answer.
Well, it is kind of nice to, it is kind of nice to know that if the numbers were not whole numbers, because that would not be fun to guess and check, right?
In which case, in the end, we would have had to do a quadratic instead of this guess and checks. Like I said, sometimes we get a lot worse numbers to work with, in which case, if my numbers are much bigger or my quadratic's much more complicated, then I'm still not going to be able to guess and check and get the proper factoring, or it might not be factorable, in which case you'd have to do quadratic
formula. Right.
And in a high-stakes test like an ACT or an SAT, they're probably hoping to push you to that point, right?
Yeah, they probably
want you to be
yes,
using a quadratic.
most likely, yes. That's very true.
Guess and check's not really going to work in those circumstances.
No, but also a valid problem-solving method if the problem is simple enough for that. So multiple methods, I guess. Good point. All right, Sam, do you have your answer to the science question yet, by any chance, that first science question?
I don't. I'm really sort of stumped by exactly what it's asking. I guess if different substances are 100 degrees Fahrenheit, I guess the way that the molecules act might mean that feeling one, like touching them, might be different. But I'm not sure if I'm missing something, if this is just something that I haven't learned, or if there's a trick to it. So I just don't know. But
I agree with you.
I can keep looking it up. Maybe I'll find something at some point.
Okay. All right, let's go back to social media and see if we can squeeze in another math question.
Okay, so this math question is, find an equation of the line containing -4, 5 that is also perpendicular to the line 5x minus 3y equals 4.
Okay, could you give me perpendicular to the line? Tell me one more time that one.
5x minus 3y equals 4.
Okay, this is a fun one. I like this one. Okay. And we need an equation of the line?
Yes.
Okay, cool. So first, let's break down. We've got enough information to help us answer this. And basically, let me maybe back up with this and tell us what we're looking for. So it needs an equation of the line. And if you're thinking about an equation of a line, it should have the format, or can have the format, y equals mx plus b. And then if you think about what this is asking, or actually, let me give you another one. We could also do point-slope form. So that's slope-intercept form. We could also do point-slope form. And that would look like this. So those are two forms that our equation for a line could look like. The way that we would choose which one we're going to do is based on what information we have. So the first one is called slope-intercept form. And this kind of makes a lot of sense, but if we're doing slope-intercept form, the information we would need to write an equation in slope-intercept form is the slope and the intercept. The form below that is called point-slope form. And the information we would need to be able to write that equation is a point or coordinate and the slope. So depending on what information we have is which format of the line equation we'll use. Now, what was given up here, you might notice we were given a point, and then I was also told that it was perpendicular to this line. So that might mean that I can at least find the information to find the slope. So I'm going to choose point-slope form to write my equation in, just because of the information that was given to me at the start of this problem. So I'm going to erase the slope-intercept form just because we're not going to use that. We're going to use point-slope form. Now, I said that we need to know a point and we need to know the slope. The point, we would replace y1 and x1. And we actually have those values. Those were given to us at the start here. We have an x-coordinate, so let's call that x1. And then we have a y-coordinate, so let's call that y1. The other part that we need for this equation is we need the slope. Now, one thing that is important to know with the slope is that we're not going to find it from our coordinate. We're going to find it from this piece of information on the right, the fact that it's perpendicular to this line. Perpendicular, just a reminder, means that we're intersecting at 90-degree angle. So these two, the slopes of lines that are perpendicular are actually very closely related. They are opposite reciprocal. So let's say the slope of one of my lines was 3. The slope of a line that would be perpendicular to it would be opposite, so negative, and then reciprocal. We flip that, we flip the number, we flip the fraction. So think of this as 3 over 1. We'll call it 1/3. So knowing that information, we're going to need to find the slope of the line up here first. And to do that, if we get it into slope-intercept form, this form, we can see what the slope is. It's always the number in front of x. So to get it in this form, one of the things that we would do is we would isolate y, get y by itself. So I'm going to move some of my coefficients, some of my terms around. I'm going to subtract 5x from both sides. That gives me negative 3y on the left, and on the right I have negative 5x plus 4. And then dividing both sides by negative 3. Then I can get my y by itself. And I have on the left, or sorry, in front of the first term, we have negative 5 divided by negative 3. It doesn't really go evenly, but we do know a negative divided by a negative is a positive. So we'll just say 5/3 x. And then plus, we'll say 4 divided by negative 3. Same thing, doesn't give me something very even, but we'll say negative 4/3. So the part that we're looking for right now is, as I mentioned, the number in front of the x, the coefficient. That's our slope. So the slope of this line is 5/3. And as I mentioned, if there is a line that's perpendicular to that, the slope is going to be opposite reciprocal. So we're going to flip it and take the opposite of it. So the slope of our line, where we're trying to fill in this equation, is going to be, so this line is 5/3. Our line, the slope is going to be negative 3/5. So now we have all of our information. We have a y1, an x1, and we have a slope. So we'll just write that into our equation. We have y minus y1, which is up here, which is 5. So we'll say y minus 5 equals, and then our slope, which we said, again, was going to be negative 3/5. So we'll say negative 3/5, parentheses x, and then we're doing minus x1. And so x1 is up here, again, with that coordinate that was given to us. So minus negative 4, which would be the same as plus positive 4. And then we have an equation. Jack, do you remember if it said in any particular form or just write an equation for it?
Just write an equation. There wasn't a particular form.
Okay. And so that's one thing in general you would want to pay attention to if you're taking or if you're solving problems with lines, is we want to make sure that our equation is in the form that is asked. But if they don't ask, any equation will be fine. So that being said, this would be an equation that would go through the line, or go through the coordinate, negative 4, 5, and would be perpendicular to the line, the equation that was given up here. So run 90 degrees. A lot of it is of working with linear equations is choosing the form and then finding the missing pieces. Sometimes you have to problem solve, sometimes they're given to you, but choose the form you want it in and then find those missing pieces. So hopefully that helps.
Yeah, I always think it's important to emphasize, like, those forms all have the same meaning in the end, right? It's all describing the same relationship, but the reason why slope-intercept form is called slope-intercept form is because you can really quickly identify the slope and the intercept.
And same with point-slope form.
Right.
You can see a point and a slope.
And the slope, right?
Yeah.
All right, so with that said, it looks like it's about time for us to go to commercial, and when we come back, we're going to hear from Elizabeth Nozick.
First half, 50 units.
When you come to a sporting event,
Do you ever wonder how the video gets on the big screen at the end of the field?
Stand by 1.
Well, the game is played out here.
Minute and a half. Cool.
A production of the event goes on in here.
2 standby. I got this job actually through networking through Emily Griffith. 2 standby, taking 2. Some of my old teachers actually got me in contact with some people here. 1 standby, taking 1.
Meet Victor Lucero.
3 standby, taking 3. I run the TriCaster and also I do scoreboard here at Glendale's Infinity Park. Come back to 1.
The TriCaster is a video switcher. He got his opportunity to learn it in the video production and editing program.
3 standby, coming back with you. Emily Griffith basically gave me the skills to 2 standby. Coming to 2. Feel confident in video production. I didn't, feel like I was going into something not knowing what I was doing. Replay standby. I felt confident enough to say like, hey, I could show up and I can produce this for you. Standby replays.
His experience began by just watching others.
The way that I learned event production is 20 seconds on video. I basically showed up here on a couple games where everybody was, they knew what they were doing. Standby 1, coming out on 1. And I kind of came in just to get a little taste of what was going on. 2 standby. Eventually I just became experienced enough to where I felt confident that they could throw me into a job. Taking 1, 3, you're clear.
Victor enjoys the demands of this position.
Standby 2, coming to 2. 2 is hot. It's a very fast pace. Can you go find the yellow team for me, 1? Go, go, go. You got it. Kind of mentality. 3, I love it. I do still do a lot of different things, but I definitely think that live production or event production is probably my favorite. Taking 1.
It wasn't his favorite part of the production in the beginning.
When I first went into this, I thought, I just wanted to do editing. And actually, the more and more as I've gone on, I've kind of gotten away from that, and I've found other things that I actually enjoy even more so. 1 coming to you.
With that said,
How much longer, Alex?
Victor has some advice.
Spread out. Taking 2. Get as much as you can because you never know. Things could change in a moment, or you could get a job doing something you didn't initially think you would end up doing, and then you'll end up loving it. Standby 1, taking 1. You're like a sponge. As a student, you're a sponge, and when you have the opportunity to get with somebody who's much more experienced than you, standby 1, you latch onto them and you suck them up dry. You try to get everything you can out of them, and I think that's a very important thing. How much longer?
Very important indeed.
1 minute, okay.
All right, well, we are back. I hope you learned a little or enjoyed learning a little bit more about Emily Griffith. So we're back with Elizabeth Nozick. She's the curator of education and exhibits at the Colorado Railroad Museum. Thanks for being on the show.
Well, thank you for having me. We're very excited to be here. I'm here mostly to publicize our new education brochure, which I brought with me, and you could put on the screen now if you'd like. They told me to say that.
Okay. So you're the curator there. Can you tell us a little bit about what that means, like what you actually do at the museum?
Well, I curate, and curator is an old word that means to care for, and it's actually synonymous with janitor, if you could believe it. But most curators think of themselves as highly intelligent, highly skilled caretakers. And I am highly intelligent and highly skilled, but I also take care of the education and the exhibits at the museum, which include taking care of historical objects such as what you see in front of you.
Oh, okay. So what do we have in front of us here?
Well, we have, and I brought a picture of the actual goose. We have a galloping goose model. We have 2 model gardens here at the museum, and the modeling goose and the model goose is a train that was made out of a vehicle. So if you look at it, it is made out of a car, but the wheels are actually rail car wheels. And what they did was, after a few years of going up into the mountains in these heavy locomotives that cost a lot of money to steam up and keep moving, is they decided they needed to do it in an inexpensive way, but the United States Post Office had a contract with them, so they couldn't not take a train up there. And there were people now who lived up in the mountains who needed the train to get there. And so they decided to retrofit a vehicle for a train, and they called them geese because as they move, they kind of move like a goose. So they kind of waddle as they move. They are absolutely beautiful. Traditionally, they are totally silver. This one has a little bit of a beige look to it. But if you come to the museum, to the Colorado Railroad Museum, you get to see some of the galloping geese that were in existence and that were dealing with the mountain communities. There's also one at Knott's Berry Farm, and there's one up in Vail.
Do any of those still run up in the mountains?
Not up in the mountains, but at our museum on Steam Up days, you may get to ride a galloping goose.
Oh, cool.
It is
That's really cool.
And
There's,
they really
there's
do
one up
waddle.
on the screen right now.
Is that one actually at your museum, or is this?
Yes.
Oh, okay.
That's one of the ones we have at the museum that we run on certain Steam Up days, which are normally a Saturday. Over the summer, we've been running train and locomotives every day. But during the winter months, during school months, we're only able to do it on the weekends on Saturdays.
Gotcha.
Can you tell us a little bit about the railroad track? I think you said earlier, it's pretty old.
Well, this is a narrow gauge railroad track from 1882.
Okay.
Can you hold it up?
Yeah.
They told me I'd be a Vanna. From 1882, and it is from the Alamosa, Colorado region. And it is just a section that was obviously cut off. This piece was narrow gauge. Now, one of the points I want to make sure I make is narrow gauge is really discussing how far the tracks are from each other. It's not the size of the track. So this is a cutoff piece of a piece of track that somebody cut a slice from. And it could also be a narrow gauge. It's all in the distance the two pieces are from each other. And the country went to standard gauge track because standard gauge works very nicely and can be a smoother ride. Narrow gauge is more useful in the mountains because as you turn a curve, and mountains do tend to have a lot of curves, you could use the narrow gauge. They were closer together and they could make those tighter curves. So the galloping geese were really great because they were small and they could go on narrow gauge. But as you were bringing supplies up to the mines, et cetera, that were up in the mountains, you really needed to be able to make those tight turns, and you needed narrow gauge to do that.
So the gauge determines how tight of a turn you can make, which makes a lot of sense if you think about radius. You know, if you have a wider gauge, you're going to, the radius is wider, and therefore you're not able to turn as much. Is that right?
The gauge allows you to make those tighter turns. The gauge doesn't. I need you to ask the question again. I apologize.
So a smaller gauge means tighter turns,
Yes.
and a wider gauge means wider turns.
Exactly.
And that's because of the rate. Like I'm thinking mathematically speaking, the
That makes sense,
radius
'cause
of turning.
When you're turning, like the outer wheels have to go further distance, right? Than the inner.
Right.
So if you're going to have that difference, right, I guess you'd have to do a lot of work to adjust a train so it can actually do that
able to-
without.
And standard gauge was adopted because it was more stable overall. So for the places that didn't need the tight
Guys are
turns,
good.
it made more
Right.
sense.
You guys
Kind
are
of the
good.
in between, the like sweet spot of like it still can make tight turns, but it still makes sense.
Exactly. So now, a lot of times in Colorado, you'll see 3 tracks so that they can go either standard or narrow gauge. Because now, because it's the standard gauge, most trains want to use standard gauge track because of how the wheels are set on the vehicle. So in Colorado, a lot of times we'll have 3 tracks so that we can go either narrow or standard.
And you can lay the tracks within them,
Well,
so they lay.
You'd use 3, so you'd lay the 3rd track within.
Ah, okay.
So they're
okay.
always using one
of them,
the
and it's
same.
just a distance from one of them.
Exactly.
Oh, that makes sense.
Yeah,
Okay.
it's kind of cool, isn't it?
It is really cool.
Is that what the third rail is? No, probably not.
Because the third rail is typically an electrically charged.
Yeah, that's what I
rail
thought. It was
to
always
move,
don't touch the third rail in the subway, and I was like, oh, maybe
Yeah,
that's
you're not supposed to pee on the third rail.
You can touch the 3rd rail, but they really don't want you to put pennies on it. And this is something I learned since working here, is that for safety reasons and to help keep the rails as smooth as they can so that the trains can run nicely on them, they don't want you to mash pennies or put things on the rail.
Right.
It's one of the big safety things that they try to teach at the museum, and when we have safety classes, it's always mentioned. And I was one of those people guilty of putting a penny on the rail when I was a
used to
kid
do
because it
that.
was
It's
fun.
the most efficient way to flatten a penny.
Yeah.
Exactly.
But don't
it's
do it.
not safe because it will hurt the train.
Could it also? I heard that it could fly out of the tracks as well.
Oh yeah.
And that's not an urban myth. That's for real.
And you start with a penny, and pretty soon I had a volunteer tell me about putting a big piece of wood on the track. And he was 5 years old at the time. He didn't kill anybody, but the engineer had quite a talking to with him.
Oh yeah.
Because they were able to stop the train, and trains don't stop on a dime. It takes quite a while to stop the train.
Right.
I have 2 more items here. I have a conductor's hat that doesn't have the emblem on it, but this is the kind of hat that would have been worn by a conductor who would check your ticket. And I have an actual ticket that would have been used by one of our Colorado trains. And what they would do is they would punch the hole to where you were going, and they'd stick it up above your seat so the conductor would know when you needed to get off.
Back in the day, how much would it have cost me to go from like Denver to Grand Junction?
I can't answer that
Okay.
question because it depends on what train you were taking
Sure.
and what kind of baggage you were taking and whether you're taking first class or regular carriage.
I mean, as a teacher, he's obviously taking first class.
Oh, yeah.
Obviously.
It makes so much money.
It's good to have a dream.
Yeah, it is something to
True.
work for.
That is true. That is true.
So, a question about you: like, what brought you to the Colorado Railroad Museum? Did you have a background in
Not in
railroad,
trains,
or just
not at all.
a curator?
My undergraduate degree is in cultural anthropology. I knew
Okay.
in 6th grade I wanted to be a museum curator. I thought the word
Wow.
curator was the most beautiful word in the English language. And so I have worked in a lot of different museums. I've worked at the Smithsonian. I've worked for the National Park Service. I have worked for the Mission Houses Museum in Honolulu, Hawaii. I've worked in a lot of different types of museums, living history, etc. Never worked for a train museum. So what they hired me for were my skills working with exhibits and education programs. What I'm learning is about trains, and I think that's what attracted me, was there was something for me to learn. I love the job because you're always learning something, and I find it fascinating.
That's very cool.
I agree. I think that's really important.
So would you be able to talk, Elizabeth, about the educational opportunities that the museum offers?
As I said, I have the education brochure you can put up. We have brand new education programs. For the first time, we are being able to address the educational programs to state standards and curriculum standards. We have a couple of new programs that we're doing for our really young audiences, which is a basic train program where we're going to identify what types of trains, and I have pictures of those as well. We have freight trains at the museum, we have cabooses at the museum, and we have some locomotives. We also have freight cars. And actually the museum has over 100 pieces of rolling stock, and we're very proud of that. A number of those pieces you can actually climb into. This one on the screen right now, caboose number 49, is one of the ones you can go inside and see what a caboose looks like in the real world and life size. Cabooses don't exist on trains today. They have another way of looking at those things, and most of the workers on a train are up in the front of the train. So this is a time period that has passed. This is a business car, and business cars were run by the superintendents of the consist, and they rode in these business cars that would have bedrooms and full kitchens and dining rooms. You can actually rent this business car at the museum and have a special dinner. If you want to propose to your girlfriend, you can do that. You can have a birthday party, etc. And this is a dining car picture from the late 40s, early 50s. And what we're talking about there is a wonderful exhibit that I did in April that will be up through the end of May, called Eating on the Rails, where we talk about the traditions of how you get food on the train. And this is probably the nicest way to get food on the train. We also talk about butcher boys, and we talk about the Harvey girls and eating houses that were along the side of the train. And we talk about how some poor people brought picnic lunches that would decay as time went by as they traveled on the train, and the flies that came and the rodents that came, and still they had to eat that. So there's a lot of variety in that exhibit. The dining car is one of the nicest parts about it.
That's, I think, my favorite thing about traveling by train versus driving or flying is the dining. I really do agree. It's my favorite.
Well, and the high style of dining is so different than what it is today. You can still travel and have that high style dining, but a lot of times you're eating a a little more on the fly, which gives you more variety. But it's really interesting to see how food rose and fell in the world of dining, and also in airplanes and things along that line. But fascinating topic, fun to look at, fun to think about.
I think it's interesting, like going back to that picture of the people dining, people used to dress a lot more formally, like riding trains or airplanes. Like I throw my sweatpants on and get on the plane now. Everybody used to wear suits and very
I
formal.
see people in pajamas on airplanes.
That would be me.
You gotta be comfortable. Yeah.
And the era of North by Northwest with Cary Grant, that era, you can still get a sleeper car and you can still have that wonderful experience, but it isn't quite as common as it once was. It used to be a part of our lives. But please, we love the idea of people coming out and visiting that era because we have some of those trains. We have a late 1940s dining car that isn't open 100% to the public, but it will be open during the Polar Express. And we offer, I don't know if you've heard of the book, The Polar Express. We have a wonderful program that runs in November and December for family audiences for certain days of the week where you can come out at night in your pajamas and have a cup of cocoa and a cookie.
You're supposed to this time.
Yeah.
My formal pajamas.
Yes.
Yes. Yes. And have a cup of cocoa and a cookie and meet Santa Claus and experience the Polar Express.
That sounds so nice.
And we
So
have
cool.
the diner open for that particular program, and you can also have the business card depending on what ticket that you purchase. It's really special.
We have other pictures too of
The
that we can
museum?
see of the 1800s. So tell us about this.
This is another image that is in the Eating on the Rails exhibit, and this is one of the first restaurant cars that you see. It's titled Hotel Car, but it's actually George Pullman's restaurant car. And if you look at the one that you saw of the 40s, it's a very different time period, but you still see a very formal dining experience when it was it was a little more expensive. It was not everybody could experience it.
Reminds me a little bit of a cruise rather than a train nowadays.
It really does look like a cruise. It really does look like a cruise. And if you notice, the server was an African-American person. George Pullman used the opportunity of hiring ex-slaves on his rail cars as a way for them to be able to make a living. And that's why you see a lot of people descended from Pullman porters. And actually the Five Points neighborhood was originated by Pullman porters who were looking for a place to stay in the Denver area as they worked on the train on the way through to California. So that neighborhood was a middle-class neighborhood, an African-American middle-class neighborhood that was founded by Pullman porters.
Wow.
Whoopi Goldberg, Mayor Webb, I can't remember his name, Wellington Webb?
Not sure.
Okay. Mayor Webb, a couple of Olympic athletes are known to be descendants of Pullman porters. So this is a very common trait. And I haven't worked here more than a year, but I meet so many people who are descended from workers of the railroad. So it's really a part of our culture, and it's
That's so
really part of who we are as a nation. Even though we don't travel by train as much, it's something that we are of. And if you look at the museum, we have an archive that is wonderful, that holds corporate records, that holds a number of blueprints on how to make cars if you want to do models, on how to make cars, model cars the way you see our Galloping Goose here. We have records that talk about how they ate on the train, which is where I went when I was doing the research for my exhibit. But there's a huge variety of things that you can see in our archive, and we're very fortunate to have that. We also have a photo of the roundhouse, which is where they go to fix the train cars, the rail cars, the rail cars, in order to run them on the track at the museum. So when we do the Polar Express, you're going to want to make sure that train runs safely.
Is it round?
It actually is in part round.
Okay.
So if you look at the top, you see the turntable, and you see those bays with the geese in front of them.
Oh, I see. Okay.
On the top of the picture.
Yes.
Though each bay is kind of like a bay where you would pull your car in to fix it, only in this case it's a rail car.
Oh, okay.
And it's a little more involved because you have to put it onto the turnstile. They have to turn the turnstile, and one man can do that. Turn the turnstile, and then they push it in with a locomotive into that bay so they can fix it. And the bay is empty underneath. And that is open, has a viewing room for public to be able to watch them work on these rail cars. And I was able to go with a visitor today while the guys were working on the truck for B8, which is one of our passengers' cars that we'll be using for Polar. And they said it hadn't been worked on since the 1920s. It is fascinating to see these cars taken apart and watch them work on them and make them run smoothly for our guests again.
Yeah, you would imagine that the tools and the parts, nothing is the same. You would have to find a lot of just different solutions for things because they're not manufactured anymore.
In many cases, they're making the parts in order to have them happen.
Wow.
So this is not an inexpensive thing that we're doing.
Right.
And we are very fortunate to get to ride the cars that we are able to ride today.
So cool. It's really, really interesting. All right, well, thank you so much for joining us, and all of the information that you gave was so interesting, really very cool. And we can we should encourage you guys to visit the Colorado Railroad Museum. Where is it located again?
It's on 44th Street, right across from Coors.
Okay.
And in Golden, just right outside of Golden, and it's beautiful this time of year. We're really lucky. The days have been just gorgeous.
So you guys better get out to the Colorado Railroad Museum. And definitely tell Elizabeth that you said you saw her on Homework Hotline. That'll make them very happy. But we're going to take a break, and when we get back, we'll answer some more questions for you and do our trivia question.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Welcome back. Hopefully you enjoyed learning a little bit about Elizabeth Nosek, the curator of the Education and Exhibits from the Colorado Railroad Museum. That was a mouthful there, but I found that very interesting, so hopefully you did as well. We're going to give our trivia question. We're running out of time, so we're going to give you our trivia question one more time, give you another chance to call in and answer, win some symphony tickets. Jack, what is our trivia question this week?
Yeah, so in case you're just joining us, the trivia question is, what is the deepest part of the ocean? Again, if you have an answer to that, go ahead and send it in over social media or call in or whatever works for you.
Whatever works for you. Honestly, best bet would just be to call using the number on your screen right up there. That would be best bet since we're running out of time. We're going to wait for you guys to call, and while we do that, we're going to try and answer one more question. Jack, what do we have?
So we're going to be heading over to science again. Science question is, why can't we drink ocean water?
Awesome. Okay, this is a great question, and I already pulled up a graphic for it. Let me just really quickly say, Nate pointed out to me at break that probably something that would help us answer the question from before about what would be the hottest substance to touch would be conductivity. So looking at the different substances that were listed, gold has the highest conductivity. It would conduct heat to another thing that touched it the easiest. So I'm guessing that is probably what they meant. So gold is probably the correct answer in that case. Anyways, to ocean water. So we do drink salt water all the time. In fact, a lot of savvy coaches will just have their athletes drink water with a little bit of salt in it, and that we could call salt water. But that's much less salty than ocean water. So ocean water is about, I looked it up just a minute ago, it's about 35 parts per thousand, or 3.5%. And 3.5% sounds like not very much, but that's a lot of salt. By comparison, a really salty soup would be less than 1% salt compared to water. And even that, we would note the salt in it. So it's really something that's almost would make you sick to drink salt water because of the quantity. But more than that, it can actually kill you. So if we could jump to my screen really fast, I'll try to go through this quickly. So there's different types of dehydration, but the kind of dehydration you would really worry about with salt water would be hypertonic dehydration, which is over here. So in hypertonic dehydration, what you want in your body is a good ratio of water to salts. You don't want too much water and you don't want too much salt. If you have too much water and not enough salt, your nerves can't fire and your body will stop functioning. But by the opposite token, if you have too much salt and not enough water, you can sort of jam up the system and you can actually end up dehydrating your cells. There's a kind of great little picture of a shrunken red blood cell here. But essentially putting too many parts, salt particles into your system is going to be something that's going to prevent your system from being able to fire what are called action potentials in nerves. Here's another really quick diagram I don't really have time to get into, but suffice it to say that level of salt is something that's going to prevent your body from functioning in a lot of different ways. So anyways, salt is good. If you get a lot of salt, make sure you drink a good amount of water to go with it. But under no circumstances should anyone drink ocean water. It's too much salt.
Like a lot of things, too much of it is a bad thing.
That's right.
Understood. All right. We're going to go get our trivia question answered.
Okay, so again, the trivia question was, what is the deepest part of the ocean? The answer to that is the Challenger Deep in the Mariana Trench is the deepest known point in the Earth's ocean. So in 2010, the United States Center for Coastal and Ocean Mapping measured the depth of the Challenger Deep at 10,994 meters or 36,070 feet below sea level, with an estimated vertical accuracy of 40 plus or minus meters. So if Mount Everest is the highest mountain on Earth, if that were placed at that location, it would be covered by over 1 mile of water on top.
Wow. I did know it was the Mariana Trench, but I didn't know it was very specifically the Challenger Deep. What else did you guys learn about Mariana Trench?
Since we're talking about the depth of it, that was actually first explored by humans when Jacques Piccard and Don Walsh descended down to a depth of 10,916 meters, which is, like you said earlier, it's about 35,814 feet, which is kind of crazy whenever you think about it, because, I mean, I've been scuba diving. When I get to like 40 feet, like all the pressure creates like a lot of issues in my ears and things like that. So I'd imagine, and Sam, you might know a little bit more about this, like if you're at almost over 34 or 35,000 feet, how much pressure is there because of all the weight?
Yeah, it's so interesting, right? Like when you go up on top of Everest, there's less air on top of you, so the pressure is lower, but it's not even really noticeable. I looked it up. The pressure under the Marianas Trench would be the equivalent of having 50 jumbo jets piled on top of you.
Just 50, huh?
Just only
Just 50.
8 tons per square inch of pressure.
So I wonder how they
per square inch. So
even design something that can
you would be crushed, and that's why they have to make those really orb-like metallic structures that are so good at taking the pressure from all angles.
Yeah.
Wow. Yeah, that's a lot.
What was the? I'm drawing the blank on the guy who went down there to Challenger Deep. Michael Bay.
His name was Jacques Piccard and Don Walsh. Did you ask who descended? Or
yeah, who descended to? Didn't somebody go into Challenger Deep? He's a famous director. He made Avatar.
So it was first explored by Jacques Piccard and Don Walsh.
Gotcha.
First.
And more recently, the guy who directed Avatar.
Well, we got to say goodbye. We'll see you tomorrow again from 4:30 to 5:30. Thank you.